chemistry for engineers. So we will introduce, no, ano bang ibig sabihin ng chemistry. So dito po ay ating i-discuss po, no, yung mga iba't ibang concept such as yung mga iba't ibang properties and the classification of matter. So as we all know, no, pag sinabi nating matter, it is anything that has space and has mass. And along this, we are going to study, no, yung mga um, units, no, of measurements and rules when it comes to significant figures, no. So let's start. Okay. So chemistry. So pag sinabi natin chemistry, that is the study of the composition, structure, and properties of matter and the changes it undergoes. So, pag sinabi natin chemistry, pinag-uusapan natin dito is yung anong meron ng isang body o ng isang matter. Okay? So, ano ba yung mga attributes na meron sa kanya? No? Ano ba yung mga features na meron sa kanya? But, it will be in terms of its composition, not only outside but also the inside. No? So that's why we have this structure and properties and some changes, no, na pinagdadaanan ng mga iba't ibang klase ng matter. Okay. So now, what are the importance, no, of chemistry in the field of engineering? Ayan. So bakit mahalaga ang chemistry pagdating po sa field of engineering? So unang-una sa lahat, okay, so we have this following engineering materials na madalas na nakikita when it comes to some engineering companies na nagmamanufacture. So, kumbaga dito chine-check, no, kung okay ba ang magiging products or okay ba yung mga materials na gagamitin. So, for example, we have the metallurgy. Ayan, when it comes to the production of steel. Ayan, mahalaga yan. Cement. Ayan, pagdating naman yan sa mga construction. Ayan, polymer, superconductors, so yung mga iba't ibang, when it comes to electrical, we have the, yung mga electrical materials like yung mga conductors, insulators. Okay, the second one is energy sources. Ayan. So, kumbaga mahalaga din ang study ng chemistry pagdating din sa pag-aagal ng mga iba't ibang sources of energy. Like for example, yung mga fuels, o yung mga gasoline, ayan, yung mga methane, I don't know kung saan yun. Ayan, basta yung mga ganon, no? Yung mga gasoline. And then, of course, yung mga about nga po sa iba't ibang klase ng energy, like yung solar energy and nuclear energy. Since pinag-uusapan nga natin as yung changes that the matter undergoes and as well as the batteries. Ayan, since ang battery kasi ay meron siyang dito, ang kanyang input po ay chemical energy. Ayan, na kanyang kino-convert naman into electrical energy. And then number 3, when it comes to the environment. Ayan, so ano bang importance ng chemistry, no, pagdating sa pagsisave niya sa environment. So of course, yan, kinalaman sa mga trees. Ayan, so ayan, so that is the importance, ayan, sa nature. Ayan, okay? Ayan. So, ngayon, again, pag sinabi nating matter, that is anything that occupies space and has mass. At dahil matter ang pinag-uusapan natin, so let's have some, of course, states of matter. So, before, syempre, ang alam lang naman natin is yung solid, liquid, gas. But, as we go along naman, is nagbabago naman po yan. So, nadadagdagan. So, let's have the solid. Okay. So, pag sinabi natin solid, basically, so, ito yung mga matter na ang kanyang particles po ay tightly packed, okay, and a regular arrangement. So, kumbaga fix yung kanyang arrangement ng mga particles. And definite, okay, so meron siyang definite shape and volume. So, meron siyang sariling shape, no, at sariling volume. So, kumbaga hindi siya umaayon sa kung saan siya nakalagay. So, yan, basically, as kung nakikita niyo naman dito sa ating picture, ayan. So, basically, yan po ang structure ng solid. Ayan. So, yung kanyang mga particles ay dikit-dikit. Okay? And kung mapapansin naman natin, fixed. No? So, meron siyang sariling identity pagdating sa kanyang structure. And then, yan. The second one will be the liquid. Ayan. So, sa liquid naman, it is composed of particles, no, in such a way na medyo maluwag na. Maluwag na yung mga particles pero dikit-dikit pa rin naman, no? So, hindi nga lang siya kagaya ng solid. Ayan, na medyo magkakadikit-dikit talaga at hindi gumagalaw at all, no? Meron siyang definite volume, no, kagaya ng solid, pero wala po siyang sariling shape. So, ang liquid, wala namang sariling hugis yan eh. Ang tubig, ayan, kasi malalaman naman natin ang hugis yan, or kumbaga, ang mga to ay umaayon lang po sa hugis or shape ng container kung saan sila ilalagay or sa lagayan. Diba? Pag nilagay mo naman yung tubig, susunod naman yan dun sa hugis ng container niya. Okay, container kung saan po siya nilagay. So, yun po. Meron siyang definite volume but definite shape. Ayan, so wala. Okay? And then the third one is the gas, no? Kung mapapansin natin, loosely na yung mga particles niya. And that's why it has neither a definite shape or definite volume. So, wala po siyang sariling volume, wala siyang sariling shape. Ayan. And then another one is the plasma. Basically, a plasma is an ionized gas, no, in which ito po ay ginagamit, no, or madalas na na-encounter when it comes to having a free electrons from atoms. So, para magkaroon po ng free electrons from atoms, so kakailanganin itong tinatawag na plasma. So, provided na dapat may sufficient energy po yan. And then number 5 is the Bose-Einstein condensate. So, medyo kakaiba ito. So, basically, ito ay kailangan ng mababang temperature. Okay? Yan. Na malapit po sa absolute zero, close to the point that the atoms are not moving at all. So, kumbaga, ito yung isang klase ng matter na kung saan yung kanyang mga particles ay hindi makakagalaw basta ma-meet niya lang yung temperature na kailangan niya. Ayan. So, ayan po yung pagdating sa Bose-Einstein condensate. Ayan. So, the next one, punta naman tayo sa classification of matter. So, yung kanina nabanggit natin is yung state of matter. And as we all know, no, pagdating po sa mga state of matter, pwede pong magbago yan. So, magbago yung phase ng isang material depende sa mga proseso niya. For example, sa solid to liquid, we have melting. Ayan. Sa liquid to solid, we have freezing. Pag solid to gas, we have sublimation. Ayan, solid to gas. No? For example, yung mga naphthalene balls, mothballs, ayan, dry ice. Ayan, solid to gas po yun. Pag gas to solid, we have the deposition. So, yung for example, yung hamog, ayan, nagkukos po yan ng particles, no? Yung parang, tawag doon, may tawag doon forget lang. Basta napropose niya yung ano. So, nangyayari ito madalas sa mga gulay, no, kapag lalo na pag taglamig. Ayan. Yung frost. Ayan, yung frost. Ayan. And then, pag liquid to gas, we have the evaporation. Pag gas to liquid, no, we have the condensation. Ayan. Okay? So, ayan po yung pagdating sa mga matter. Okay? Now, we have the classification of matter. So, basically, ayan po kung napapansin nyo sa ating diagram. Yan. We have the matter is divided into two. No? That is the mixture and the pure substance. Ayan. So, ayun, ano ba pag sinabi nating pure substance? Basically, it has a definite composition and distinct properties. So, dahil pure, meron siyang sariling identity. Ayan. Okay? So, meron siyang sariling identity. At yung mixture naman, basically, it is a combination of two or more pure substances. Okay? Provided na yung mga substances na yun na nakahalo doon ay nare-retain pa rin nila yung kanilang properties. Ayan. So, parang ang system lang naman dito, kung mapapansin nyo po, may arrow siya dito. No? Wherein, ang mixture, pwede siyang ma-separate, no, into pure substances by physical methods. Kasi nga, sinabi kanina na yung mixture is composed of pure substances. Ayan. So, yan po yan. Pagdating po sa pure substances and mixture. So, yan. Any mixture components can be separated by physical means. So, mamaya aalamin natin yan kung paano gagawin dyan. Okay. Now, let's go to the first, yung pure substance muna tayo. Yung nasa kanan ng graph. So, pag sabi natin element, no, that is the simplest form of matter since it contains only one kind of atom. So, hindi siya na-divide into another particle kasi ito na yung magiging pinaka-simplest form ng kahit anong klaseng matter. Since meron lang po siyang nag-iisang atom. And as we all know, yung mga elements na yan yung matatagpuan natin sa periodic table. Okay, compound, so this is a pure substance naman that contains two or more elements being combined in a chemical means. Or, pwede rin na-combine siya by a definite proportion by mass. So, nagkaroon po ng hatian o ng partition, no, pagdating po sa mass ng mga elements, no, para malaman natin, okay, yung nilalaman ng isang element o ng isang compound. Ayan. So, basically, ang compound naman ay nasa-separate naman po yan into elements by chemical methods. So, by chemical means po na paghihiwalay na yung compound into elements. Ayan. Okay, then punta naman tayo sa mixture. We have the we call this the heterogeneous and the homogeneous. Pag sinabi natin homogeneous, so that is the composition, no, provided, or the composition of pure substance in which there will be a uniform composition. No? So, ayan po. So, ang mahirap lang dito, dahil unique yung composition ng isang homogeneous mixture, so hindi natin madaling ma-identify kung anong nilalaman niya. So, for example, ng homogeneous mixture is yung mga salt solution, sugar solution, na pag hinalo mo yung salt at saka yung water, so matutunaw yung particles ng water. So, hindi na natin siya ma-identify kung yun ba ay tubig o tubig na pala na may acid. Ayan. While yung heterogeneous particle or mixture, so dito naman ay nare-retain ang chemical properties, okay, kapag pinaghalo-halo. Ayan. So, yan. For example, syempre, yung halo-halo. Ayan. Okay, yung tipong pinaghalo na po yung mga substance, pero madali po natin silang ma-identify. Okay? Madaling ma-distinguish pag heterogeneous. And heterogeneous can be classified furthermore into suspensions and colloids. No? So, meron pa tayong dalawang klase ng heterogeneous mixture. So, those are the homogeneous and the heterogeneous, the suspension and the colloid. Yung suspension naman, basically, this is a type of heterogeneous mixture in which the solid particle does not dissolve in liquid. So, hindi natunaw kaagad, no, yung mga solid particle dun sa liquid. Okay? While yung colloid naman, somehow, ay, tawag dito, meron siyang mga particles ranging between 1 and 1,000 nanometers in diameter. Okay? So, ang mahirap nga lang dito, syempre, dahil ito ay heterogeneous. So, somehow, no, yung kanyang composition ay distributed din or uniform. So, hindi nga lang kagaya ng homogeneous mixture nga lang. So, again, ulitin lang po natin na yung any mixture components can be dissolved by physical means. While yung compounds can be separated by means or by chemical means. Ayan. So, yan po yung pagdating sa matter. So, ito naman po yung mga iba't ibang paraan on how we are going to dissolve or we are going to separate the mixture into physical means. So, yung una, yung nasa taas na diagram is water solution po siya. Okay? So, may solution po dito na pinapainit. Okay? And being evaporated into dryness. No? So, magbibigay po yung water vapor ng water component pa. No? So, ayun po yung mga parang tawag dito, paraan natin para ma-separate natin yung mixture by chemical means. Ayan. So, yan. Then, number 2 is, ito naman yung pagdikit. Okay? Use the magnet to remove the iron fillings from the sand. Okay? Yan. So, yan po yan. And since the sand will be not attracted to magnet. Ayan. So, kung mapapansin nyo, di ba? Ayan. Okay, so, para madali nating matanggal or mapaghiwala yung iron fillings sa sand, so, gagamit ka ng magnet. Ayan. Okay. So, let's go now to the properties of matter. So, ito po yung ilan sa mga properties na kailangan taglayin ng bawat klase ng matter. So, number 1 is the physical properties. So, basically, these are the properties that does not affect the identity and the composition of a substance. So, hindi pwedeng magbago yung isang substance, okay, kapag may physical properties. Ayan. So, ano-ano ba yung mga example ng physical properties na alam natin? No? Of course, we have the color. So, madali siyang ma-identify kaagad. Density, boiling point, melting point, at marami pang iba. Yan. So, yan naman yung pagdating sa physical properties. And then, along with that, we have the physical changes. Basically, these are the changes that cannot alter, okay, or cannot change the substance or the property and the composition of the substance. No? For example, the melting, and freezing, breaking, crushing, cutting, etc. So, pag kinat mo ba rin naman yung papel, papel pa rin naman yung nagiging resulta. Ayan. So, yan po yung pagdating sa physical properties at physical changes. Ngayon naman, we also have the chemical composition or chemical properties wherein the matter undergoes the changes, then nag-iiba na po siya ng structure or nag-iiba na po ng identity. So, that is, for example, we have the heat combustion and combustion heat, flammability, acidity, reaction with water, and etc. So, marami pong yan, pagdating po sa chemical properties. Speaking of chemical properties, we also have the chemical change. So, basically, tinatawag din po siyang chemical reaction in which that the substance is being converted into another substance. Okay, so, example are digestion, temperature, color, composition, hindi, chemical reaction pala yun, sorry. Ayan. So, mga example po ng chemical change, ayan, digestion, respiration, burning, casting, at marami pa pong iba. Decay, syempre, pag nagbabago na po yung property o nagbabago na po yung tawag dito, structure ng isang matter, so, ayan po yan, under na po yan ng chemical change. So, paano ba natin masasabi na nagkaroon po ng chemical change o ng chemical reaction? Yan. So, dito na papasok yung, let's say, pagbabago sa kulay, changes of color, changes of temperature. So, ayan, madaling mainitan or madaling magbago, yung substance kapag pinainit, or pinalamig. Change of composition, so kapag, let's say, yung asukal nasunog, so magiging maitim na siya. So, nagbabago na ng composition. Pag formation of gas, ayan, so nakakabuo po ng mga gas and ng precipitate. Ayan, galing po sa, ayan, usually galing yan sa mga smoke or sa mga ulap. Ayan. So, ayan po yung mga iba't ibang properties, na pwede nating ma-check sa isang matter. And aside from that, we have the extensive and the intensive properties. So, pag sabi natin extensive, so hindi po siya nakadepende, or hindi po, nakadepende sa size ng sample, ayan, size, ayan, and other properties. Basta may kaparehas. Ayan. So, example niyan is yung mass, volume, and length. So, ayan po yan. Okay, nakadepende ka sa size. No? Pero kung hindi naman, so, intensive property, syempre, we have the density, temperature, boiling point, malleability, conductivity, at marami pa pong iba. So we have the measurement. So, ito naman po yung ilan sa mga basic quantities na ginagamit, and then yung kanilang corresponding SI unit, So, we have the following quantities. So, we have the length. So, basically, that is the distance between 2 points. Ayan, 2 separated points. Ayan. Mass, wherein it measures, yung tawag dito, yung sa inertia. Ayan, and of course, it affects the weight of the body. Then, yung time naman, ayan, pagdating naman po sa mga events, temperature, okay, so that is the, what we call this one? It measures the heatness, okay, the hotness or coldness. Ayan. Electric current, so this is the rate of flow of the electric charge, ayan, or the electrons. Amount of substance, so this is the size of the three-dimensional body, okay, or sabihin natin yung sa number of particles po yan. Luminous intensity, that is the amount of, what we call this, okay, amount of the light, Kumbaga nakadepende po siya dun sa liwanag na nare-receive, okay, nag-receive sa isang particular na location or direction. So, ito po yung kanilang mga SI unit. Para kay length, we have the meter, mass, kilogram, time, seconds, temperature, Kelvin, or absolute, yan, zero. Pinatawag din po yung absolute zero. Electric current, ampere, amount of substance is mole, and the luminous intensity is candela. So, ngayon naman, we have this following prefix, no, for the powers of 10, na pwede natin gamitin, no, to express, okay, the number in scientific notation kung halimbawa ay napakaliit or masyadong maliit or masyadong malaki. Okay? So, ito po yan. So, ilan sa mga yan ay ang mga nakalagay sa table. So, syempre, ang mga madalas na ginagamit dyan is yung giga. Okay? So, we have G, 10 raised to 9. Mega, M, 10 raised to 6. Kilo, 10 raised to 10 raised to 3. Rather. Centi, 10 raised to negative 2. Milli, 10 raised to negative 3. 10 raised to negative 6 micro, 10 raised to negative 9 nano, at minsan, ayan, 10 raised to negative 12 pico. So, yan lang yung mga ilan sa kanila. No? So, pagdating po sa prefix for powers of 10. So, kapag po, halimbawa, you are going to involve the operation, okay, pagdating po sa mga ganitong klaseng dito, yung gagamit ka ng prefix, no? So, it is important na madali natin siyang ma-express into scientific notation. So, better yet, no, yung mas magandang way, no, to deal with this, yung mga ganyang malalaki or maliliit na number is to express them into scientific notation. And then, you can use, no, yung count, yung factor. Ayan, yung factor ng bawat prefix na ginagamit. So, para madali mo siyang ma-express and madali mo ma-operate. Okay. Now, let's go to the significant figures. So, basically, these are the digits that carry a meaning in a number and contribute to its precision. So, kumbaga may kinalaman po dun sa pagiging precise ng mga values, no? Kung halimbawa po, magkakalapit naman po yan, so definitely ay meron silang parang tawag dito, number, no? Kumbaga paano tawag doon? Parang magiging guide number. Ayan. Na kung saan doon malalaman kung significant pa yung mga iba pang mga numbers. Yan. So, kino-consider natin dito yung precision No? Pag sabi kasi natin precise, no, yung pagkakalapit-lapit ng mga values doon sa totoong value, di ba? Pag sinabi natin precise. So, usually, ito naman din ay ginagamit, no, in order to express, no, yung mga iba't ibang measurement values. Ayan. So, kaya malaking bagay po ito, no? Ayan. So, now, let's have some examples here. Okay. So, any zero or any digit that is not zero is significant. So, obvious naman yan siguro, no? Ayan. Pag yung non-zero digits, so may consider silang or considered na significant. So, wala na tayong problema dyan. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Pag sinabi namang zeros between non-zero digits are significant. So, yan. For example, we have 406. Yan. Meron siyang tatlong significant figures. Yan. So, of course, maglagay tayo ng unit kasi, yun nga, let's say 406 centimeter. Ayan. So, meron po siyang tatlong significant figures. At dahil nga yung zero ay nasa pagitan ng non-zero, so significant na po yan. So, ito, balikan lang natin. Of course, let's say 156. Yan, meter. Yan. So, we'll have 3 significant figures. Yan. Okay, then zeros to the left side of the first non-zero digit are not significant. So, for example, yung mga 0 point, yan. So, for example, no, yung mga 0.0001. Ayan. Okay? So, for example, 0.0001. Pero ang totoo naman pala is, ayan, isa lang. No? Ayan. So, isa lang yung kanyang So, you will have 1 SF. Ayan. Kasi lahat ng 0 before the non-zero digit ay hindi po significant yan. Now, if a number is greater than 1, then all zeros to the right of the decimal point are significant. So, halimbawa, we call this, let's say, we have 3.0. So, meron pong dalawang significant figures yan. So, meron pong dalawang significant figures to. Okay, since, ayan, all the zeros, okay, lalo na pag greater than 1, to the right are significant. Ayan. So, yan naman yung pagdating po sa, sa pag-identify ng significant figures. Of course, this is grams. Ayan. And then, if the numbers is less than 10, then the only zeros that are at the end and in the middle of the numbers are significant. So, medyo nakaka-confuse, di ba? So, paano ba natin maitutuging na zero? Siyempre, kapag may zeros, okay, applicable to pag mga decimal. Pag may zero, doon siya, yan. Or, yun. Yan. So, as long na yan po ay, yung zero na yan ay nasa dulo, no? Kasi, ayan, yung zeros at the end of the number. So, lalo na pag mga less than 1. Ayan. For example, mga 0.0450 or 440. So, meron pong tatlong significant figure yan, or tatlo, ayan, dalawa na. Tatlong significant figure, wherein ang mga significant figures po dyan, yung dalawang 4, at saka yung isang 0 nakatabi ng 4. Kasi, ang dahilan po niyan is pwedeng pong ano yun kasi, baka pwede ang nakuha mong value is 0.0442. Hindi ka 0.0439 or 38, diba? So, maraming possible na pwedeng maging to. Okay, kaya we are not sure. Pero, since naka-express naman po siya in decimal places, no, it can be rounded off na lang or exacto, so we have to consider that. So, ayan. So, ayan. Okay, so pagdating po yan sa significant figures. And then, when it comes to the calculations involving the significant figures, pag addition and subtraction naman, tawag dito, syempre, i-align natin. No? Especially yung may mga decimal numbers. Okay, yung may mga decimal part. So, kagaya nito, na example natin, 89.332 plus 1.1. So, yung 3, o yung unang 3 ng 89.332 ay naka-align dun sa pangalawa ng 1. Kasi since malapit sila dun sa decimal point, no, yung 3 and 1, kaya lang nasa kanan. So ngayon, pag pinag-add natin yung dalawang yan, so 89.332 at 1.1, so you will get 90.432. Or rounded off na lang natin into 90.4. So depende naman po no, kung hanggang ilang significant figures na po yung kailangan natin. Ayan. So, well, we can round off naman. And then, pagdating naman sa division or sa subtraction, so we have 3.70 minus 2.9133. So, dun sa may 3.70, ayan, so meron pa siyang karugtong na mga zeros. And since 2 decimal places lang yan, and yung isa naman is 4 decimal place, so magdadagdag lang tayo ng dalawang 0 dun sa kanan ng 0 na katabi ng 7. Okay, so para ma-operate natin. So, we can have 0.7867 or 0.79. Okay. Now, when it comes to multiplication or division, so, wala namang kaso dito as long na the number of significant figures is the same as the number of significant figures in the quantity having the smallest number of significant figure. Ayan. So, well, magde-depends naman po tayo sa magiging operation eh. Then, we can choose to round off. Ayan, so we have 400 or 4.51 times 3.666, 6666, ayan. Or simply, 16.5 pag na-round off po siya. Pag naman, divide, 6.8 divided by 112.04, so we will have 0.061. Okay. Ngayon naman, punta tayo sa accuracy and precision. So, gaya ng sinabi ko kanina, yung precision ay medyo, may kinalaman po yan sa pagkakalapit-lapit ng mga set of values. While yung accuracy naman is para malaman natin kung malapit po yung nakuha natin dun sa actual na value. Pero ang precision, again, magdedepende po yan sa mga set of measurements. Okay? And then, titignan na lang or i-check kung gaano ka-close. Ayan. So ngayon, of course, pagdating naman sa mga mathematics, importante pa rin yung mga conversions. Okay, so we have the length. Ayan, so nakalagay na po dyan, 1 meter, 1 inch, 1 inch, ayan, 1 mile, ayan, 1 foot. Pag sa mass naman, we have the kilograms to slug. Ayan, so yan po yung mga iba't ibang constants, okay, or conversion factors na pwede natin magamit. Sa volume naman, we have 1 ml and equal to 1 cubic centimeter. Yan. And then 1 ball is 1,000 milliliter. Yan. Okay, so yan po yung ilan sa mga yan. Pagdating po sa accuracy and precision. So, now let's go to temperature conversion. So, of course, as you all know, marami pong iba't ibang units ng temperature. We have the Celsius, Fahrenheit, Kelvin, and Rankine. Well, we have the degrees Celsius and the degrees Fahrenheit having their relationship to each other. No, we have for the degrees Celsius, we have 5/9 times the degree of Fahrenheit minus 32. And then for the degrees Fahrenheit, so that will be equivalent to 9/5 degrees Celsius plus 32. So, yung 32 naman kasi is of course, alam natin na may kinalaman po yan pagdating po sa Fahrenheit, di ba? And kung titignan natin yung maigi, no? So yung temperature formula ng Fahrenheit, mas mataas kaysa doon sa Celsius. So, mas mataas po. Okay? Yan. Okay, so ngayon, ayan po, yung R, sinabihan na degree, Rankine. Okay, pag Kelvin at saka Rankine naman, hindi po sila absolute. Yan, so they are not absolute. Yung ano lang po, yan, yung Celsius at saka yung sa Fahrenheit. So, we have to learn on how we are going to convert of that. So, of course, alam natin na we have the different temperature like yung sa boiling of water, 100 degrees Celsius. Pagdating sa Fahrenheit, that is 212. Ayan. At dahil meron tayong 273, pagdating po kay Celsius papuntang Kelvin, so you will have 500. Ayan, August. Ayan. Sorry. Ayan. Okay. Pag tinagta kami naman yung 100 plus 273, you will have 373. So, yung pag kinonvert mo naman yung Celsius o yung Kelvin, galing sa Celsius, ayan. Pag galing ng Fahrenheit, papuntang Rankine, so you will have plus 460. Ayan. So, okay. So, might as well, ito na lang po muna yung gagamitin natin, no, para mas madali po natin i-convert. Ayan. So, we are going to use that. And then, pag body temperature, usually 37 degrees Celsius, diba? Pag room temperature, around 25 degrees Celsius, ayan, or 20. O, may nagsasabing 20, may 25. Okay, then of course, the freezing point is around 0, ayan, degrees Celsius, or it can be also 32 degrees Fahrenheit. Ayan. So, yun lang naman, no, pagdating po sa pagko-convert ng temperature. So, don't forget that, no, kasi of course, mahalaga din yan, no, pagdating po sa mga values or sa temperature. Okay. Now, here are some other derived units like this one. Area, of course, makukuha yun sa pamagitan ng product or pag-multiply ng dalawang dimensions. Especially pag mga square or rectangle, diba? Yan. So, having a unit of square meter, yung volume naman, which is the amount of the space that an object occupies, so that would be in cubic meter. Density, okay, so that is the mass per unit of volume. Okay, so i-divide mo lang yung mass sa volume para makuha mo ang density. So, ang density pwedeng in terms of kilogram per cubic meter. Yung speed naman or velocity, kung walang direction, no, speed, the ratio of distance traveled to a time interval. So, yan naman po yan. And of course, the unit there is meters per second, ppm, or tinatawag din parts per million. Tinatanong natin kung usually, ang inaalam dyan is ilang particular substances ang meron sa 1 million. No? 1 million particles na nasa sample. Ayan. So, pagdating po yun sa ppm, usually sa mga hangin, ayan, mga dust, ayan. Okay? Then the force, Newton ang kanyang unit. So, that is also equivalent to its derived unit, kilogram meter per second squared. Pressure, And force per unit of area. So that's why the unit there is Pascal, no, equivalent to Newton per square meter. Energy, okay, that is the rate of doing work. So, ayan, 1 joule. So, you will have 30. So, ayan. Okay, 1 joule is 1 Newton meter. Then, pag power naman, that's the rate of doing work or energy. So, that will be equivalent to joule per second. Ayan. So, pagdating po yan sa mga derived units. And of course, marami pa pong iba pang derived units na pwede mapagamit or magamit sa chemistry. So, ngayon punta naman tayo sa dimensional analysis method of solving problems. So, ito yung tipong kailangan mo i-convert, no, yung mga iba't ibang units or iba't ibang measured values from one unit to another unit using the conversion factor. Ayan. So, ito lang naman po yung mga kailangan natin tandaan. Of course, alamin natin, no, kung anong unit conversion factor ang ating gagamitin, depende po dun sa given. Pangalawa is, ayan, carry units through calculation. So, halimbawa naman, magkakaparehas naman sila ng unit. And alam mo na yung unit na yun ang nasa final answer. So, yun, pwede rin yung gawin yun. Okay. And, yun, syempre, yung cancellation, importante yan sa lahat. If all floor, yan, all units, yeah. Okay, cancel, except for the desired unit. Okay. So, ayan. Gagamit ka nga ng conversion factor. Ayan. Yung tipong, halimbawa, yung sa given unit, let's say, meter, then gusto mo siyang gawing centimeter, so pwede naman yung centimeter over meter. Ayan. So, gamitin mong conversion factor. So, we have 100 centimeter over 1 meter as the conversion factor. And then, makukuha mo na yung hinahanap natin. Okay? Ayan. So, now, okay, so let's have some example problems here. Okay, so for letter A, we have 0.0823 pounds to milligrams. So, i-convert natin yan gamit yung mga conversion factors. So, let's start with letter A. Yan, 0.0833 pounds papuntang grams. Okay, so we can have 0.0833 pounds. Then we can have, okay, so pwede natin gamitin yung 2.2 pounds kada 1 kilogram. And then, doon naman sa may, sa kilograms, pwede natin siya i-convert into 1,000 grams. And then, after that, yung grams, okay, gagawin na natin siyang milligram. So, gamit yung 1 milligram, yung milli, ibig sabihin po niyan is 10 raised to negative 3, diba? And so, we can have 1 times times 10 raised to negative 3 grams. So, okay, pag ginawa natin yan, so ang makukuha natin dyan will be, yan, so pwede natin makuha dyan is 300 or 37,863.64 milligrams. So, ayan. So, yan yung makukuha natin sa letter A. So, ganun lang po. So, tandaan lang po natin yung mga conversion factors. So, let's try letter B. So, we can have, okay, so, ang tanong naman doon is 275 liter to 2 cubic meter. Okay, so yun naman yung tanong, no? So, we can have 275 liter. So, pwede natin iteretsyo na lang ng 1,000 liter kada cubic meter. So, pwede natin makuha is 0.275 liter. Or pwede naman, then, gusto mo nang medyo mas mahaba, pwede naman natin gawing, let's say, 1,000 milliliter kada 1 liter. Tapos, yung 1 ml, pwede natin siyang gawing 1 cubic centimeter o yung 1 cc, di ba? Tapos, gamit yung conversion factor ng 100 centimeter kada meter na naka-cube lang, so makuha pa rin natin the same or 0.275 liters. So, ayan po. Okay. So, ang susunod naman na tanong doon is yung letter C. Yan. So, let's have yung letter C. So, ang given po doon is 0.2 808 gram per cubic centimeter papuntang kilogram per cubic meter. So, gagawin lang natin guys, no, is pwede na natin siyang gawin. Yan. So, ang gagawin lang natin muna, yung grams muna, syempre. So, we can have 1,000 grams kada isang kilogram. And then, gamit yung conversion na 100 centimeter kada meter, then i-raise lang natin sa 3. So, ang lalabas po dyan is yung 0.808 times 100 raised to 3 divided by 1,000. So, we can have 808 kilogram per cubic. Okay. So, next po tayo. So, letter D. So, we have 105 degrees Fahrenheit to Kelvin. So, ang gawin lang natin muna, so, i-convert natin yung convert muna natin yung degrees Fahrenheit papuntang degrees Celsius para yun ang maging way natin para ma-convert natin siya sa Kelvin. So, using the formula, no, yung pinakita natin kanina, so we can have 5 over 9 times 105 minus 32. So, we can have, so pag kinumpit natin yan, we'll get 40.56 degrees Celsius. Then, after that, pwede na i-convert sa Kelvin sa pamamagitan lang po ng pag-add ng 273 na nakuhang degrees Celsius. And you will get the... So, this is just an approximate lang naman. Yung sa Kelvin. Yan. And then, proceed tayo, letter E. So, ang tanong naman doon is 8.314 joules per mole Kelvin papuntang liter ATM over mole Kelvin. So, bali pa ang convert lang natin dito is yung yung joules papuntang liter ATM. So, ngayon, ang ATM stands for atmosphere. So, it is a unit of pressure. So, gamitin natin yung conversion na 1 ATM equals 101,325 Pascal. Ayan. Okay. Now, okay, so okay na yan, no? Gamitin natin yung conversion na yan. But of course, sa ating solution, syempre yung joules, alam natin na ang joules is 1 Newton per square or Newton meter, diba? Okay. While yung Pascal is actually, that is 101,300 Pascal is Newton per square meter. So, kung i-regulate natin, no, i-convert natin itong Newton meter in such a way na meron po siyang Pascal. So, pwede natin siyang gawing, no, yung Newton magiging Pascal square meter na naka-multiply pa sa meter or simply magiging Pascal cubic meter. So, parang sinasabi natin na yung joules is Pascal cubic meter. Okay. So, now what we're going to do is, so i-convert na natin. So, we have 8.314. So, yung joule, gagawin na natin Pascal cubic meter over mole Kelvin. So, i-convert lang natin yung Pascal muna. So, we have already 101,325 Pascal. Yan, kada isang ATM. Okay. Then, isa naman, no, yung cubic meter, gawin nating liter. So, we can have 1 cubic meter, 1,000. So, pag ginawa natin yan, so, ang makukuha dapat natin is 0.0821. So, gagawin lang natin siyang hanggang 4 decimal places lang. Pero ang kasunod nito is 8205. Liter ATM, then mole Kelvin. Yan. So, ayan po siya. No? Okay. So, para dun sa ating susunod na problem na letter F. So, we have the given there 2 horsepower to pound or pound foot and pound horse foot, ayan, or foot pound per minute. Okay. Now, ito yung mga kailangan natin i-take dito conversion. So, as you all know, 1 horsepower is basically 746 watts. So, a unit of power. Okay. Yun. And then, 1 pound force is actually equivalent po yan sa 1 slug, yan, feet per second squared. Yan. So, of course, ito yung mga kailangan natin pang-abangan ng mga conversions, no? Pagdating po sa, ayan, when it comes to, ayan, yung mga conversion factor when it comes to conversions. So now, let's convert, no, yung 2 horsepower, convert natin sa watts. So we can have 746 watts per horsepower. Ayan. So maka-cancel po yung HP dyan. And then yung watts, syempre, as you all know, yung watts, that is joules per second. Diba? Yung joules naman is Newton meter. So, pwede na natin gawin is, okay, yung 1 watt is maging 1 Newton meter per second. Yan. Okay. Kaya alam, may problema tayo kasi yung no, yung Newton dito. Okay. Ngayon, pwede natin gawin, guys, is, gawin natin, no, yung Newton, gagawin natin kilogram. Diba? O yung Newton, gagawin natin siyang kilogram. Sige, gawin natin 1 Newton, magiging 1 kilogram meter per second squared. Yan. Okay? So, ayan. And then, okay, sige, isa-isahin na natin yung mga kailangan convert. So, we can have yung kilogram papuntang slug, that is 14.59 kilogram. So, babalikan natin kanina yung conversion. Okay, so na-convert na natin sa slug. So, madali na lang yan. Now, yung meter. Okay, kaya lang, dalawa yung meter natin dito. Tama ba? Okay. Kaso, ginawa natin joules per second. Sige, yung seconds muna. No? Or, ang gawin na natin siguro, dahil dalawa naman yung meter, sige. Ang gawin na natin, convert natin yung meter papuntang feet. So, we have, okay, 1 meter, tapos 3.28 feet. But since dalawa yan, isi-square natin. Ayan. Okay? So, para mas madali po siya. Ayan. Then, after that, yung, yung seconds naman. So, yung seconds, nasa bandang, baba. So, dito, gagawin ko siyang sa taas. So, 60 seconds kada isang minute. Ayan. Okay, so, makukuha natin dito. Okay, pag ginawa natin yan, so we can have 2 times 746. Then, divided by 14.59 tapos times 3.28 squared times 60 seconds. So, we can have yan. Yan. So, pag ginawa natin yan, ang makukuha natin is yan, 66,000. Okay. Yan. 66,000. 6,010.42. So, ano pa yung mga units na na-cancel, no? So, yung kilogram, okay, slug, okay, nandiyan pa yung slug. Tapos, yung okay, feet square. Okay, ayan, nandiyan pa sila, no? Tapos yung second squared, tapos yung minutes. But since nabanggit natin kanina na yung 1 pound force is 1 slug feet per second squared, so yung slug mawawala na dito, then yung second squared mawawala na din, then dahil isang feet lang naman ang kailangan ng 1 pound force, so may matitira kang feet. Okay, so that's why we look and pound force, tapos may matitirang isang feet, tapos yung okay, so yan po yung pagdating natin sa conversions, okay, gamit yung mga iba't ibang units and factors. So, titanium is used in airplane bodies because it is strong and light, no? Okay. It has a density of 4.55 kilogram or gram per cubic centimeter. If a cylinder of a titanium is 7.75 centimeter long and has a mass of 153.2 grams, so calculate the diameter of the cylinder. So, we are looking for the diameter or dimension of the cylinder. So, ang pinakamaganda natin gawin is gawin natin is okay, so given yung density, no? Then, yung mass given. So, pwede natin gamitin siguro yung formula ng density. So, yan, mass over volume. Okay. So, hanapin natin ang volume. So, pamagitan ng mass over the density. So, ang mass natin is 153.2 grams. So, although hindi nga naka-SA yung ating pero naka-compatible naman yung mga given natin. So, kaya okay lang naman. Then, 153.2 gram divided by 4.55 gram per cubic centimeter. So, you will have 33.67 cubic centimeter. At dahil ito ay isang cylinder, so gamitin natin yung formula ng volume ng cylinder, pi r squared h. So, wherein, pag dinerive natin yung formula, we can have r, or the radius. Since dyan po manggagaling yung diameter, di ba? So, we can have square root of volume divided by pi h. So, still naka-centimeter pa rin tayo. So, we can have 33.67 cubic centimeter divided by pi times, ano yung height? So, yung height natin is actually yung length, no? Yung 7.75 centimeter. So, pag ginawa natin yan, okay, so, magiging 1.176 centimeter. At dahil ang diameter is twice ng radius, so we can have 2 times that. So, 2.352 centimeter. Now, let's have this one. A magnesium is a valuable metal used in alloys, batteries, and in synthesis. Okay. Now, it is obtained mostly from seawater that contains about 1.3 grams of magnesium for every kilogram of seawater. So, kumbaga, kada isang kilo ng seawater, there's a 1.3 gram of magnesium there. Okay. So, now what we're going to do is to find the volume of the seawater in liters first, and then followed by so volume of seawater needed to extract 8 times 10 raised to 4 tons of magnesium, okay, which is roughly the annual production in United States. Yeah. So, given the density of the seawater is 1.03 gram per m. So, gagawin natin ngayon, so, hanapin natin is yung volume. So, simulan muna natin sa pamamagitan po ng pagko-convert. Okay, so, or yung sinasabing kanina, ang dimensional analysis. So, ngayon sisimulan natin ang lahat dun sa given. Okay, so ang gawin natin, magsimula tayo dun sa 8 times 10 raised to 4 tons of magnesium. So, ang gagamitin natin pang-convert ng tons papuntang, let's say, pounds. Okay, siguro sa pounds muna tayo. Or pwede rin namang sa kilo. Okay. Okay. But, siguro maganda gamitin na lang natin is yung 1 ton. So, this is actually 1 short ton. No? And then, we have 2,000 pounds. Yan. Kasi pag hindi po sinabi na, let's say, ton lang. So, ito po yung gagamitin natin conversion. Meron din tayo tinatawag na metric ton. So, iba pa yun dito sa ton na binabanggit. Okay. So, 1 ton is 2,000 pounds. Then, yung pounds, gawin natin kilogram. Yan. Tapos, yung kilogram, gagawin pa natin, dapat, so, 1 kilogram ay 1,000 grams. Ayan. Okay. At pagkatapos, okay, ayan. So, and then, okay, so gawin natin. Patapos yan. So, 2,000 na yan. Okay, so cancel na po dyan yung tons, then yung kilogram, then matitira grams. Okay, so sabi kanina, no, kada, okay, 1 kilogram daw ng seawater, okay, didepend lang natin, or yan po ay correspond sa 1.3 grams of magnesium. So, nagkaroon po ng comparison kasi dito eh. So, yung 1 kilogram daw ng seawater, equivalent sa 1.3 grams ng magnesium. So, cancel na yung magnesium, no? So, matitira yung kilogram seawater. Okay? And then, after that, convert na naman natin. Conversion. 1 kilogram, tapos 1,000 grams. Tapos, okay, gamitin na natin yung density ng seawater, which is 1.03 grams per milliliter. And then, pwede nating gawing ano to, no? Gawin nating liter. So, we have 1 liter, 1,000 milliliter. So, dahil yun ang tanong. So, pag ginawa natin yan, so cancel out po yung tons mg. Yan. Yan, mg. Yan, cancel na yan. Then, yung pounds, ton, ayan, cancel na nga. Then, kilogram dito, cancel. Grams, ayan, ano pa? Kilogram dito, ayan, then yung grams, tapos yung ml. So, ayan. So, bali makukuha po natin dito is 5.432 times 10 raised to 10 liters of seawater. Okay? So, ayan po yan. At what temperature does the numerical reading on a Celsius equal on a Fahrenheit thermometer? So, okay. So, gagawin lang naman natin. Okay, pag-equalin lang naman natin, no? Okay, so pwede natin gamitin formula, yung sa formula ng degrees Celsius, papuntang degrees Fahrenheit, o yung baliktad. So, siguro ang magandang gamitin ko na lang is degrees Fahrenheit equals 9/5 degrees Celsius plus 32. So, ang hinahanap natin is yung kung saan sila magiging magkaparehas. So, siguro gawin natin, let's say, gawin natin silang in terms of letter T. Yan, T. Yan. Gawin natin equal sa T. Yung degrees Fahrenheit at degrees Celsius. And then, ayan, so pwede natin i-solve yung T. So, ilipat lang natin itong 9/5T sa kapila. So, magiging ano yan? Magiging negative. T minus. Ayan. Tapos, we can have negative 4/5. Then, 4/5T is equal to 32. Then, multiply na lang natin sa 5. So, times 5, 160. Divided by negative 4. So, makukuha natin is negative 40 degrees Celsius. Ayan. Okay, so negative 40 degrees Celsius or negative 40 degrees Fahrenheit. So, ayan po yan, no? Okay, pagdating po sa ganyang problem. Okay. And the last problem na ating isa-solve for today is this. Ayan. The chlorine, okay, is used to disinfect swimming pools. Now, the accepted concentration for this purpose is 1 ppm chlorine or 1 gram of chlorine per million gram of water. So, ito yung kanina binabanggit natin na meron sinasabing ppm. Ayan, di ba yung ppm, that stands for per million. Ayan, parts per million. Ayan. Okay, now calculate the volume of the chlorine solution in milliliter a homeowner should add to her swimming pool if the solution contains 6% of chlorine by mass and there are 2 times 10 raised to 4 gallons of water in the pool. Now, 1 gallon is 3.79 liters, so binanggit. Density of water is 1 gram per ml and the density of the solution is 1 gram per ml. So now, again, kagaya ng ginawa natin kanina sa number 3, so ang gagawin lang natin is dimensional analysis. So, simulan natin ang lahat since manggagaling po kasi lahat sa, okay, hanapin kasi natin kung ilang chlorine solution ang meron doon sa swimming pool. Na ang swimming pool is may 2 times 10 raised to 4 gallons of water. So, okay. Water na lang. Pero kung naalala nyo naman sa inyong chemistry class before, so water is H2O. So, ulitin lang po natin, no? 2 times 10 raised to 4. So, magsisimula lang sa 2 times 10 raised to 4. Yan. Gallons. Then, gallons ng water. Ayan. And then, i-convert natin siya. Siguro natin sa 3.79 liter per gallon. Okay, ayan. Pagkatapos yung liter, i-convert natin sa ml. Ayan. Kasi we are looking for the amount in ml, diba? So, kaya ginawa natin siya. And then after that, gamitin natin yung density ng solution. So actually, manggagaling pa lang kasi ito sa solution natin. Ayan. And then pagkatapos, gamitin natin yung binanggit na parts per million niya, which is 1 gram daw ng chlorine ay katumbas daw ng 1 million grams. So, gawin ko na lang 1 million grams ng water. Yan. Okay, then pagkatapos, yung 1 gram ng chlorine solution, yan, katumbas ng 0.6 or 0.06 grams ng chlorine. Okay, sir, saan mo nakuha yung conversion na yan, no? Okay. So, nakuha natin yung conversion na yan since may binanggit po siyang 6% chlorine by mass. Ibig sabihin, sa 1 gram ng solution, merong 0.06 gram ng chlorine. Okay? So, naglalaman po ng 6% ng chlorine yung isang solution. So, now, and then finally, ibalik natin. Kasi ang hinahanap naman natin dito is milliliter. So, gamitin natin ulit yan, 1 gram per. So, bali makukuha natin dyan is around 1,263.33 milliliters of chlorine solution. Yan. Kasi ang ina natin is gaano karaming chlorine solution. So, kaya kinailangan po natin siya i-convert, okay, from the grams water papuntang grams chlorine, then grams chlorine papuntang grams chlorine.